So lesson 5.8 in your algebra book is called probability without counting. And your big idea, the probability that a point lands in a particular region can be calculated by taking the ratios of measures of regions. So we're going to be calculating probability, but not just with numbers in a word problem. We're going to look at pictures and diagrams and talk about basically how much of the space is taken up by one object and another object, and then use that to kind of form a probability based on those percentages. So let's take a look at example number 1. I think it'll make more sense. So suppose a dart is thrown at a 24-inch square board. So here's your 24-inch square board. If it's a square, it's 24 inches on every side, containing a target with a circle of a radius of 3 inches. Now, if you notice, this says 6, but this says 3 because this is 6 all the way across. Just a reminder, that's the diameter of the circle, and the radius is halfway across from the center to the outside. So that's why the radius is 3, and this says 6 all the way across. So assuming that the dart hits the board and that it's equally likely to land on any part of the board, what's the probability that the dart lands in the circle? So we want to say, what's the probability that it gets inside this circle? And now we're not taking into account the skill of whoever's throwing it. So obviously a professional dart thrower is going to have a higher percentage of making it in here than somebody who's never thrown a dart. So we're saying that there's an equally likely to land on any part. All right, so no skill involved. We're just saying it's all equal. Basically, how much of this square is the circle taking up as a percentage? That percentage also represents the probability that it's going to be there. So we think about when we use numbers for probability, it's always the favorable outcomes over the total number of outcomes. So that's kind of what we're going to look at here. The favorable outcomes would be hitting in the circle, and we're going to compare that to the total number of outcomes, which would be hitting anywhere inside the square. We set those up as a ratio. You divide, you get a percentage, and that also represents your probability. All right, so let's start with the big area. We're going to have to compare the area of this to this. So let's start with the area of our square. Area of a square is base times height, length times width. You can call it whatever you want. In this case, it's going to be 24 times 24. And that's a total of 576. Now this was inches times inches, so that's inches squared. So the area of the square is 576 inches. Now we need to find the area of the circle. Remembering back, cherry pie's delicious, apple pies are too. So for area, apple pies are 2. Area equals pi times the radius squared. So the biggest mistake people make with circles is they take the diameter and they plug it in for radius. So please make sure that when you plug in for radius, you're using the number that represents from the center of the circle to the outside. And they told us that's 3. We also could just look at this. If the diameter is 6, the radius is half, so it's 3. So this is going to be pi times 3 squared. 3 squared is 9, and we're going to leave this as just 9 times pi. So I flipped the order here. We're going to treat pi kind of like an x when we're connecting numbers to it and putting a coefficient in front. So pi is always going to come second. Instead of writing pi 9, you're going to write 9 pi, like 9x or 9y. But this is still a number. You technically could go and turn this into a decimal right now. But if you're going to do that, you're going to have to write down that big long decimal and then bring it over here and use it. So if you just leave it as pi and then wait to turn it to a decimal till your very final answer, I think it's just going to make things a lot easier for you. All right, so if we want to find the probability, so we want to put our favorable outcomes over our total number of outcomes. That's just in general what probability is. What's the chance of this happening compared to chance of anything happening? So in this specific case, we're going to be comparing the area of the circle to the area of the square. So if there's an equal chance of hitting anywhere on this board, what's the probability that it ends up landing inside this circle? So we're going to compare the circle to the whole area. So let's plug those numbers in. The area of the circle is 9 pi, and the area of the whole thing is 576. Now, inches squared is going to cancel on both spots. And so basically we have to take 9 pi divided by 576, and that's going to tell us the percentage. So depending on which calculator you got, we're going to go 9 pi divided by 576. Now we get this long decimal. Okay, and remember we're looking for a percentage here. When we divide this, we get a percentage. So we got to move this 2 spots. Okay, so it's 4%. Let's be a little more exact, 4.9%. Okay, it goes 2 spots. So between the 4 and the 9, there's a 0 after the 9, so there's no need to round that up or do anything with it. So 4.9%, or just 5% is fine as well. Okay, approximately 5%, approximately 4.9. Even the 4.9 is approximate because there were more numbers after the 9. We're going to just round them off and leave it 4.9. So technically it's approximate. All right, so similar to finding probability in other cases, we're just looking at the picture. Favorable outcomes, so what's the chance of hitting inside here compared to all the outcomes, the chance of hitting anywhere on the board. All right, example number 2, similar, a little different. So all of these points, A, B, C, and D, they represent exits on US 31, so the highway. So we're on the highway. An accident occurs at random along this stretch of highway. Calculate each of the following. Now, each one of these distances here represent miles. It says, what's the probability of an accident happening between A and B? So that stretch between A and B, that's your favorable outcomes. So I'm just going to abbreviate here real quick. Your favorable outcomes is the distance from A to B. It's what we're measuring. So what's the probability of the accident happened between A and B? That stretch is 10 miles. And you're going to compare that to the entire stretch here. Well, how far is the entire stretch? 10 plus 3 is 13, plus 7 is 20, plus 8 is 28. So this whole stretch of highway is 28 miles. We want to know what's the probability that out of those 28 miles, the accident happens between A and B. Well, that's a 10-mile stretch. So AB represents 10 out of 28. Now, you could divide that and get a percentage. You could also just simplify it. The miles are going to cancel. Divide by 2. You could call this 5 out of 14. If we wanted to get a percentage, 5 divided by 14 looks like this. So about 36% chance. So when you're doing your homework on any of this and you look at the answer key, if you left your answer like this and you see 36% or 0.36 or something like that on the answer key, know that your answer is not wrong. You can give it either way. Or vice versa. If you gave a percent and they left it as 5 over 14, they're just different ways of expressing the same thing. Okay, so one's not better than the other. Sometimes you're going to see it one way, sometimes you're going to see it another. There's no way for you to know which way to give it unless it specifically says give your answer as a percent or leave your answer as a ratio or a fraction. So if it doesn't say that, any of these are fine. So don't look at the answer key and think you're wrong. All right, so the probability of an accident between B and D. So we're going to put our favorable outcomes, which represents the actual distance between B and D, and our total number of outcomes, which we already know is 28. So the distance between B and D, so this whole distance. So we know this is 3 from B to C. We know this is 8 from C to D. So altogether, that's 11. So we have 11 miles. Miles are going to cancel here. Okay, so you have 11 out of 28 chance. And if we want to turn that to a percentage, come over here, it looks about 39%. So approximately 39% chance that the accident is between B and D. So either one of these would be just fine. All right, let's take it up a notch now. If you flip it over, okay, we got another circle, so we're gonna have to use our pi r squared formula. And it's broken into different pieces, and we're gonna have to be able to find the area of these different rings. So the little circle, the big circle, but also the rings. So we'll talk about how we're gonna do that. So these are all evenly spaced. If you notice, the radius here is 2, This next ring has a 2, and this ring has another 2. So it's all even. It says if a point is selected at random from inside this, what's the probability of each of the following? So look at what we're going to have to do if we glance down. We're going to have to find the probability that it lands in that outer ring, which means we're going to need that area compared to the total. And with the inner ring, right here, the darker one, we're going to need to compare that area to the total. And then the bullseye, which will be your little circle, so we're going to compare that area to the whole thing. So first thing we have to do before we even worry about probability is we have to go ahead and find the area of the full circle, the little circle, and the rings. Medium circle is going to be part of that. And then once we have that, we can set up our ratios comparing those regions to the total, just like we did on the front, to find our percentages and our probability. Okay, so let's start with the big circle. The radius of that big circle from the middle to the outside is 6. 2, 2, and 2. So if we're going to find the area of that, apple pies are 2. Radius is 6, so it's 6 squared, which is 6 times 6, so 36. And we're going to leave pi alone. So we're going to leave our answer as 36 pi. And this is inches squared. Area is always squared. Okay, so the area of the whole thing, which is what we're always going to be comparing this to when we're talking about probability, what's the chance you hit this little region? We're going to compare that region to the whole thing. So we're going to be comparing everything to 36 pi. That's the total number of outcomes. That covers all of it. Now, the ring that's a little smaller, so we're talking about this shaded ring and the little circle, so all of that, that has a radius of 4, 2, and 2. Okay, so if we're going to find the area of that, we're going to plug in 4 for the radius. So 4 squared, 4 times 4 is 16. We're going to leave our answer as 16 pi inches squared. So we just said, what's the chances that it hits inside this medium circle? So it could go in any part of it. That represents 16 pi in the area. And then the actual bullseye here, the little circle, has a radius of 2. And so we're going to plug in 2. 2 squared is 4. So we're going to get 4 pi inches squared. Now, if you look at these questions, we need to find the probability that it fits in the outer ring. So we need the area just of this ring. So far, we've only found the area of the circles themselves. So you think about, how do I find the area of just this outer ring? Well, that would be the area of the whole thing, taking away this inside. You take this inside away, you cut it out, and you're left with this outer ring. So what we have to do, so this is your big outer ring. We're going to label this nicely. If we want to find the area of the outer ring, we take the area of the whole thing, which is 36 pi. And we're going to cut out or eliminate this inner circle, not just the little one, but this whole part. And that's going to leave us with just the outer ring. So we're going to subtract this inner circle, the medium circle, which we said is 16 pi. So we're going to subtract 16 pi, cut out 16 pi from the full circle, from 36 pi. And that's going to leave me 20 pi. So the outer ring itself is 20 pi. So what about the inner ring, this darker color in here? So for this one, we're going to take the area of the full circle inside of that ring, full thing, and we're going to cut out the little circle. And when you eliminate the little circle, you're left with the ring. So the area of this medium circle with a radius of 4, we know is 16 pi. And if we eliminate or subtract out the little circle, take 4 pi away from it, that's going to be 12 pi. And the bullseye we already know, but like we can write it here so it all matches up. Your bullseye is 4 pi. and that's just from right here. The bullseye is that circle. So do I have to write it again? No, but just to make this all even. So we've got the 3 full circles, and now we've got the rings and the bullseye. We've got all the information we need now. We can start setting up these ratios. So we're going to put our favorable outcomes over the total. So if a point is selected at random from inside of this target, what's the probability that it hits the outer ring? So again, you're putting your favorable outcomes over your total outcomes. So your total outcomes is hitting anywhere on this. That's the big circle. So our total here is going to be 36 pi inches squared. And our favorable outcome now is just hitting the outer ring. What's the chance we hit the outer ring? So how much of the total does the outer ring actually take up? So the outer ring, we said, was 20 pi. So the outer ring takes up 20 pi inches squared of the total 36 pi inches squared. And so we're going to convert that now into a percentage. Now the pi's are going to cancel, so it was really nice. Instead of dealing with all those nasty decimals, just leaving pi in this, it ends up canceling out altogether. So we're good. Inches squared is going to cancel out. So we have 20 over 36. Well, we can divide those by 4, and we're going to get 5 over 9. And that'd be a good probability right there, 5 out of 9. Or if we want to convert this into a percent, let's go ahead and divide. So 5 divided by 9. Move it 2 spots. 55.5, 55.6 if you're rounding it up. So 55.6% goes 2 spots. Looks like 55.5, but the next number rounds it up to 55.6. All right, so you have about a 55.6% of hitting that outer ring if they're all equal. Again, no skill involved. All right, now we're going to find the probability of the inner ring. So again, you're putting your favorable outcomes over your total. So our total is not changing. It's 36 pi inches squared. The favorable outcome now is the inner ring. What's the probability of hitting this inner ring? Well, the inner ring is taking up 12 pi inches squared of space out of the total of 36. So when we set up this ratio, we can cancel anything that cancels. Inches squared, pi cancels. We have 12 over 36. You can divide those by 12. 12 goes into 12 once. 12 goes into 36 3 times. So it's 1/3. Or we know what this looks like. 1 divided by 3 is 0.3 repeated. So what percent is that? Move it 2 spots. It's 33.3. No rounding up because all these numbers are 3s. So we would call this 33.3%. Now remember, these are approximate because we did do some rounding. And then the probability of getting a bullseye here, again, favorable outcome compared to your total number of outcomes. Total is 36 pi. Our bullseye takes up 4 pi. So compared to the total of 36 pi, the bullseye is 4 pi. So what's the percentage that it's taking up? What's the probability of hitting that spot? So we'll cancel everything we can cancel. You're left with 4 over 36. Simplify it, divide them by 4. So you get 1 and you get 9. We can leave that. Or we can divide 1 divided by 9. And you get 0.1 repeated. What percent is that? Move it 2 spots. 11.1. No rounding up. And again, that's approximate. We did cut off numbers, so approximately 11.1%. Now, have we covered everything? We got the bullseye, and we got the ring, and we got the other ring. So if we added up all of these probabilities, that should cover all of it. That should be 100%. If we're expressing those as fractions, it should be 1. So using my calculator, I'm going to double check myself here. 5/9 plus 1/3 plus 1/9 equals 1, or 100%. If you added the percents, you get 100%. Now, we did do some rounding. In this case, I do believe here we're going to get 100%. But if you did some rounding, you might get 99.9% or something like that based on your rounding. But with the fractions, which are exact and they're not rounded, which is why we like fractions better than some rounded decimal, when we add up all of these probabilities, we have accounted for 100% of the possibilities. So when we add all these up, we get 1 or 100% because we've accounted for all of this.